Welcome back to StudyOnion. Today we're going to be talking about historical models of the solar system and the issues that ancient astronomers faced when trying to come up with their theory of the universe. So, let's first explore retrograde motion and what that meant for ancient astronomers. Now, retrograde motion is simply the zigzag or sort of loop-de-loop motion of the planets, which you can see on a night-to-night or daily basis. Now, why you can see this is because of the Earth simply overtaking a superior planet on the inside of its orbit. But this caused huge problems for ancient astronomers who were trying to explain how the solar system worked. So early models of the universe was based on geocentric theories, and it was systems created by ancient Greek philosophers such as Plato and Aristotle. The Aristotelian Universe was based on 4 elements: air, water, earth, and fire. It was a system of concentric crystalline spheres which were driven around by a prime mover. And this carried celestial objects like the moon, the planets, sun, and other just stars around the Earth. Now, while the sublunar sphere was changeable, temporary, and corruptible, and this is how they explained the Earth and its imperfections, the heavens, or the superlunar sphere, was seen as being perfect and unchanging. Now, this was a difficulty for ancient astronomers because this doesn't explain the observed retrograde motion of planets in the sky. To modify this theory and make it suit the observed retrograde motion of the planets, each planet had to be placed on a small rotating circle, and this circle was called the epicircle, whose centre revolved around the Earth on another circle, and this was the deferent. So you have the Earth at the centre of the deferent, and you have an epicycle which centre lies on the deferent, in which the planet orbits around. A little complicated, you might think. So Ptolemy's ideas were slightly different. The planet revolved around the epicycle as we saw before, but you have an off-centred Earth from the deferent, you have the centre of the deferent, and you have a new thing called the equant. And the equant was basically the point which the angular motion of the centre of each epicycle was uniform. Now, this is a bit difficult to understand, but essentially, the centre of the deferent was the centre of the circle, the equant was the point in which the angular motion of the epicycle was uniform. Now, this was all very complicated, as you might think. So, the modern ideas began with the Aristarchus of Samos, which we've seen before with his creative ideas on measuring distances. Now, Aristarchus was the first astronomer to propose the heliocentric model. So heliocentric means sun-centric, whereas geocentric is Earth-centric. But the heliocentric model didn't really gain acceptance until a much later period of time. And this is where Nicholas Copernicus comes in. So Copernicus applied some mathematical modelling and advocated for a heliocentric or sun-centred universe. So a model with the sun at the centre would reduce the need for an equant and epicycles. So this model gained acceptance in the late 16th century. But astronomers were quite eager to reduce the disagreement between the predicted positions of the planets and where they actually were. And this is where Tycho Brahe and Johannes Kepler come in. Tycho was particularly interested in the motion of the planet Mars and plotted its position very accurately over 20 years. So his assistant Kepler was then able to analyse this data and formulate his 3 laws of planetary motion, which we'll be looking at next week. Now, Galileo also provided some evidence to support this. So the apparent size of the planet Venus changed and showed phases, and this meant that the universe wasn't unchanging, and it meant that the Earth couldn't be at the centre of the solar system. We also have Galilean moons, or Galileo called them satellites, and these were the 4 moons which orbited the planet Jupiter. The 4 Galilean moons are now Io, Ganymede, Callisto and Europa. And this showed that Earth couldn't be at the centre, because if other planets were being orbited by different moons, it meant that the Earth wasn't the only one. Now, this all was evidence that they used to prove the heliocentric model, and this is what has gained wide acceptance in today's world. But these were the steps that was needed to get to this point. So, to summarise, the Aristotelian universe was based on 4 elements: air, water, earth and fire. It was a system of spheres carried by the prime mover, and they believed that the sublunar sphere was changeable, temporary and corruptible, while the heavens were perfect and unchanging. To modify this theory, each planet was placed on a small rotating circle, an epicircle, whose centre revolved around the Earth on another circle, called the deferent. Ptolemy came along and gave the idea that the off-centred Earth was not at the centre of the deferent, but rather there was a point which was the centre of the deferent and a point called the equant, from which all the angular motion of the epicircle was equal. Through Ptolemy's adjustments, subtle modifications to the Greek model, this was able to more closely match the observed motion of the planets. Aristarchus of Samos was the first astronomer to propose a heliocentric model, but this model didn't gain acceptance until a later period. Nicholas Copernicus came along and applied some mathematical modelling and advocated a heliocentric universe. A model with the sun at the centre would reduce the need for an equant and epicircles, making the model much less complicated. This model gained acceptance in the late 16th century, but astronomers were keen to reduce the disagreement between the predicted positions of the planets and where they were in actuality. Using Tycho Brahe's carefully plotted Mars data, Kepler formulated his 3 laws of planetary motion. Galileo also provided evidence to support the heliocentric model, including the apparent size of the planet Venus showing phases and changing, and the 4 Galilean moons, Io, Europa, Callisto and Ganymede, which orbited Jupiter. Thank you very much for watching, and I hope you learned something from this video, and tune in next week to learn more about the Kepler's laws of planetary motion. But for now, see you guys! Bye!